previous video I was also told you about the types of bond. Basically the two types, one is the electrovalent bond and second one is covalent bond. Now in this video we study the electron dot structure as well as the orbital structure of the ionic compound. So before we start the electron dot structure or the orbital structure of ionic compound, first of all we should here know a term. The term is electrovalency. Electrovalency. So you already studied the electrovalent bond. So I am saying here electrovalency is such a atom of an element which has tendency to lose or gain of electron to form a ionic bond. So the atom of an element whenever loses or gain of electron to form an isolated gaseous atom and to become finally there is electrovalent bond, then there is termed as electrovalency. So see what I am saying here. The atom of an element lose or gain of electron to form an ionic bond, or electrovalent bond, then we say electrovalency. As we all know that the metal, their valence electron is there 1, 2 or 3. Number one. Second thing, non-metal, their valence electron is 5, 6 and 7. So what we know here? We know here that the valence electron in metal 1, 2, 3 has tendency to lose their electron, while non-metal the valence electron 5, 6, 7 has the tendency to gain their electron, so that to become stable, to fulfill the inert gas electronic configuration. So that's why I am saying here, so how much the amount of electron either to lose or gain of electron for the formation of ionic compound, then it is known as what? Electrovalency. So here whenever I am saying the ionic bond is formed, then we always know that the ionic bond is formed between the metal and non-metal. So one side the metal loses gain electron and from another side the non-metal gaining electron. So when the metal lose electron and non-metal gain their electron, so that the bond is formed there, the bond is termed as what? Ionic bond, or you say the electrovalent bond. So whatever the electron loses as well as gain their electron, then that very electron is termed as what? Electrovalency. Now after knowing this thing, we start the electron dot structure as well as the orbital structure of the ionic bond. See, first we start here electron dot diagram. Or you say the Levi's dot structure, also you say electron diagram of ionic compound, or you say the electrovalent bond. So electron dot diagram of ionic compound, or you say electrovalent bond. So how we make here electron dot structure, see here. By giving example, I am saying here, take an example of NaCl. Clear? So in NaCl, first of all we write the atomic number. We know that the atomic number of sodium is 11. So the electronic configuration is 2, 8, 1, K cell, L cell and M cell. In K cell, the 2 electron is present here. In L, 8 electron, and in valence cell, that is outermost cell of an atom known as valence cell, 1 electron is here. So next, chlorine, atomic number 17. So the electronic configuration is 2, 8, 7, K cell, L cell and M cell. Here we see what? The 7 electron in their valence cell. So now what we know, to become a stable, the sodium, one of the electron which is present in their valence cell loses there to become a stable, while the chlorine gain their 1 electron to become a stable. So see, so here we make a 1 dot. So whenever we representing here electron dot, you may either give in this way dot, you circle or crosses in this way, so that we differentiate between the elements. So sodium is there, how much electron is here? 1 electron, because 1 is their valence cell. So I represent here 1 electron. Now in chlorine, their valence electron is there how much? 7. So we 7 crosses here. See what I am saying here. At the time of the formation of ionic bond, the sodium loses their 1 electron. So if the sodium loses their 1 electron, then what? It gains 1 electron here. Chlorine gain electrons from sodium to become a stable. So see, Na plus charge. So one of the sodium lose their electron and the chlorine gain their electron to fulfill the inert gas electronic configuration. So that's why I am here written Na plus charge. Now chlorine, after gaining 1 electron from sodium, see here the minus charge is here. So what I am saying here, listen carefully. I am saying here one of the electron loses by the sodium to fulfill the inert gas electronic configuration, while the chlorine gain their 1 electron so that it to become a stable to fulfill the inert gas electronic configuration. So what I am written here, I am written Na plus charge, because one of the electron loses by the sodium, so Na plus, while in another the chlorine gain 1 of the electron. So here sodium loses and chlorine gain of electron. So this lose or gain of electron to become a stable, that form a ionic bond. Now this one is the electron dot diagram. Now orbital structure, when we make orbital structure, then see how. This one is the electron dot orbital structure. Second one is orbital structure. How we represent orbital structure? Because this one is not important, but we have see here. Three cell is here, because sodium 3 cell, atomic number is, as you know, the 11 is here. So in K cell 2 electron, L cell 8 electron, and now in M cell 1 electron is here. And see in chlorine, how much cell here? See 1, 2 to 4 to 6 to 8. Now in M cell So crosses you apply here because to differentiate. Crosses you apply. Not is similar. Here 8. 2 to 4 to 6. Here. One of the electron loses by the sodium. So what happened here? See, two cells only, because one of the electron lose from here. 2 to 4 to 6 to 8, and here see, here the one electron 2 to 4 to 6 to 8, here now 2 to 4 to 6 and one of the electron. So see what I am saying here, when one of the valence electron loses from the sodium, then the chlorine gain one electron. So what we see here, the 2 orbital is left, and in here chlorine, one of the chlorine is gaining their electron from the sodium to become a stable. So what we see, the one of the losing electron and second one is gaining electron to become a stable. So this one is the orbital structure of the ionic compound. Now take another example so that it become more clear that how we represent the electron dot structure as well as orbital structure. Electron dot diagram of, you see, ionic bond, more clear, or you say electrovalent bond. See, I am giving you another instance. Here magnesium chloride. Magnesium chloride. The formula is MgCl2. So what we know, the atomic number of magnesium is how much? 12 here. So we write first electronic configuration 2, 8, 2. And in chlorine, their atomic number is 17. So their valence. So how we write here? Electronic configuration 2, 8, 7. See, here the 2 electron in their outermost shell of magnesium, and in chlorine there is how much electron here? 7 electron. So chlorine need to lose their 2 electron to their 2 chlorine atom so that it to become stable. In another way, the chlorine gain 2 of the electron from their magnesium atom so that it to become stable. So see how. Here the magnesium 2 electron and chlorine 2 to 4 to 6 and one is there is 7. So here the 2 electron loses by the magnesium. So see, Mg2 plus here. Why I am saying magnesium 2 plus? Because the 2 electron loses so that it to fulfill the inert gas electronic configuration, and this one chlorine gain 2 electron from magnesium. From magnesium. One of the chlorine gain here and second one also chlorine gain. Second one also chlorine gain. So here the 2 electron is loses by the magnesium, while the chlorine gaining of 2 electron. So by losing of 2 electron and gaining of 2 electron, so represent here magnesium 2 plus charge and one of the electron minus 1, and here one of the electron minus 1. So in another way you also write MgCl2, because one atom of the magnesium loses 2 valence electron to their 2 atom of chlorine, so that to become a stable, to fulfill the inert gas electronic configuration. So this one is the electron dot structure. So now see the orbital structure. How we draw a orbital structure of magnesium chloride. See here magnesium. We know the atomic number is there is what? 12. I am written here, so there is no need to be write again. Magnesium atomic number 12, electronic configuration KLM 282. So see here 2, 8, 2 in K cell, L cell and M cell. Here the 2 electron. Now here 8 electron will not to be represent as in the dissimilar form. Here the same way we represent dot here 2 to 4 to 6 and to 8. See, and now outermost electron, what? 1. Clear? Now next one, there is what? Chlorine. How much chlorine here? 2 atom of chlorine here. So you write here chlorine here as in the form of orbit 2, 8, 7. Here the 2 electron, 2 to 4 to 6 and to 8. And now this one is the what? 7 electron. 2 to 4 to 6, 1, 7. So by representing cross here, why we differentiate easily. So that's why here again another chlorine atom. See here. Here the 2 electron, 8 electron. Clear? Now outermost electron there is what? 7. So 2 to 4 to 6. Here you represent 1 so that it easy to 2 to 4 to 6, 1, 7. See here magnesium loses their 1 electron. See here magnesium loses their 1 electron so that it to become stable, to fulfill the inert gas electron. If 2 electrons lose from there and chlorine gain 2 electron, so see what happens when this one is loose, then what happened? Only the 2 cell is remain here. Why I am saying 2 cell remain here? Because the valence cell which contain 2 electrons loses 1 electron in both sides. That is a 2 atom of the chlorine. So that's why I am saying here 2. First you say fulfill here 2 electron is here, 2 to 4 to 6 and to 8. See here the 2 electron loses, so here what? We make 2 sign here, 2 plus charge, that is what cation. And now here we see the orbit 1, 2, 3. Orbit is remains same here. Gain of electron is here. So 2, 8 electron in second orbital, and in third orbital what we see here, one of the electron received by the magnesium. So in this way you write, see, one of the electron received from magnesium, this one chlorine atom, see what, minus charge, and in this side also here the 2 electron, 8 electron in their second orbit. Now in third orbit also it becomes stable to gain 1 electron from magnesium. So here again you mark minus charge. So what you see here, the 2 electrons removed, or you say the loose, by the magnesium so that it to become a stable or to fulfill the inert gas electronic configuration, while the chlorine gain one electron from the magnesium so that it to become a stable. So this one is the orbital structure. Clear? Now next, take one more example so that it become more clear. I hope this one is clear. So take one in another example, another instance we say here, that is calcium oxide. Take here electron dot structure of calcium oxide, CaO. So what we know, the calcium atomic number is what, 20. So the electronic configuration is here 2, 8, 8, 2 in K cell, L cell, M cell and N cell. Now in oxygen oxides, their atomic number is 8. So electronic configuration 2 and 6 electron in their valence shell. So see here, the calcium need to lose 2 electron, clear, to fulfill the inert gas electronic configuration, while the oxygens required 2 electron so that to become a stable or to fulfill the inert gas electronic configuration. So what I am saying here? I am saying here, suppose here the calcium, the 2 electron, now oxygen 2, to 4 to 6. Now here the 2 electron loses by the calcium. So what you see here, calcium 2 plus charge. Why I am saying calcium 2 plus, that is electropositive charge. Why I am saying, because the 2 electron lose so that to become a stable, while the oxygen gain 2 electron. Gain 2 electron. So here 2 minus charge, or you write Ca 2 plus or O 2 minus, or you simply say CaO, calcium oxide. So what you see here, the electron which is present in the valence shell of a calcium atom, they lose their 2 electron, and while the oxygen gaining of the 2 electrons. So here, while the formation of the ionic bond, we already know that the force of electrostatic force of attraction is there is what, high. So if the electrostatic force of attraction is high, so that the electrons need to be attract. It means that there is repulsive force is also there, but repulsive force is there less in comparison to their electrostatic force. So that's why I am saying here, while the formation of ionic bond, the electrostatic force is more in comparison to the repulsive force. So that's why they always form the word ionic bond, or you say the electrovalent bond. So this one is the electron dot structure. In the same way, we draw the orbital structure also. I hope this one is not need to be draw orbital structure. As previous I give the two instances of sodium chloride and magnesium chloride. Here again we draw orbital structure. The first cell 2, then after 8, then after 8, then after 2, and 2 of the electron loses there. So one outer cell, that is a valence cell of an atom, be reduced there. Only 3 cells remain, and after that gaining of the 2 electrons is here. So the number of cells remains same here, but in spite they gain the electron to become a stable. Now we discuss here the electron dot structure as well as orbital structure. Now we study some physical properties of ionic bond. So what we know, what the physical properties? Number 1, they have hard crystalline solid. Why I am saying the ionic compound have hard crystalline solid? So what the meaning of crystalline? Just you see in initial that looks like crystal structure. Crystalline means that the solid substance which has a fixed geometrical shape. So whenever the solid substance having a fixed geometrical shape, then it is said to be what? Crystalline. So all the ionic compounds basically hard and crystalline, solid in a structure. This one is the first physical property. Second, they have high melting and boiling point. They have high melting and boiling point also. There is much need energy to break their bond because the electrostatic force of attraction there is what? So high. So that's why it need so much energy to break their bond. Third one, they conduct electricity in molten state and aqueous solution. What I am saying, they conduct electricity. When it conduct electricity, it will conduct electricity whenever the sodium chloride is in the form of molten state or is in the aqueous state. Why? The reason is here. Whenever the sodium chloride in molten state, then their ion free, and if their ion is free, then it easily conduct electricity. Why? Because the water has a tendency to break their ions. So that's, I hope so in 9th standard you already know that water has a unique property that is also termed as high dielectric constant. So what the high dielectric constant means? That the water is the property to break their ions. So whenever the water is added in an ionic compound, then the water break their ions. So if their ion break by water, so that can easily pass their electric current. So that's why I am saying, because their ion become mobile, and once the ion become mobile, so that the electric current can easily be passed in a ionic compound. So that's why I am saying. Now, this one is the third physical properties of the ionic bond. Now, here we see what fourth physical properties. They have generally soluble in water but insoluble in organic solvent. So what I am saying here, listen, I am saying here basically all the ionic compounds generally soluble in water. Generally I am saying here, some of the insoluble also, but most of the ionic compounds were generally soluble in water but insoluble in organic solvent such as petrol, diesel. These all are the organic solvent where the sodium chloride or any ionic compound not dissolve in them. So here these all are the physical properties of the ionic compound, and here we just remember these all things, that whatever I teach in this class. Now in next video I will discuss the other types of chemical bond. The name of the bond is covalent bond, and how the covalent bond form, what is the polar and non-polar covalent bond. So in next video we study about the other types of bond. Thank you.